This rule checks for excessive coupling of high-speed traces to input and output nets. High-speed traces switch at a very high rate. They can affect the I/O signals on board. This is an EMI issue where the noise from the printed circuit board can disrupt the functioning of other boards or other electronics near it. This rule is run on connectors and I/O nets, which means if there are no connectors or I/O nets identified by your setup, you will get a setup error. Adding IBIS models is optional, but if added, HyperLynx will use edge rate information from it. Some of the parameters this rule uses are as follows. Edge rate is the maximum allowable rise time or fall time the net should have to be included in the check as an aggressor. Threshold frequency is the minimum frequency of the net that the check will identify as an aggressor. Maximum run length is the total maximum allowable length for which the aggressor net and victim net are coupled. In most cases, coupled length is the length for which the aggressor is running closely and in parallel to the victim net trace. Minimum separation is the minimum allowable separation between the victim net and the aggressor net. If the distance between two nets is less than the minimum allowable separation, they will be marked as a violation. We can decide whether to include return current coupling and component noise coupling in the consideration while calculating coupling. We also need to specify a victim net object list. Once all the parameters are set, we can run the rule and investigate the violations in detail. Clicking on the violation highlights and zooms to the nets affected. The areas where coupling exceeds the threshold is marked by red. In this case, we can see that the net exceeds the maximum allowable coupled length and the separation is smaller than the value specified in the parameters. We can investigate the effects of these violations further in the simulation, or the layout engineer can increase the spacing between the nets and take precautionary measures such as adding guard bands, etc. This way, HyperLynx DRC catches EMI issues that might have not been caught otherwise.